Okay, today we're going to look at some problems from section 6.3 and 6.5 in our textbook, derivatives of exponential functions. Primarily, there's the bell, start class. Primarily we will be working with base E, though we'll do a little bit with other bases. Okay, so here we're going to take the derivative, and remember the derivative of e to the x is just e to the x. And then the derivative of e to the u, which u is some other function, would be e to the u times du dx. So here we're using the chain rule, which is what you'll see most often. So here we have y prime. So this is e to the u. So we have e to the u times the derivative of u, which would be 1 plus 2x. We want to make sure that's in parentheses. Since we're multiplying times that binomial there. Okay, so over here, this can be a little confusing when we see the e squared. One of the things to remember is e squared is just a number. It's no different than 2 squared or 3 squared, so this is a scalar. So the derivative, just like the derivative of 5x would be 5, that would be e squared. And then minus derivative of e to the x is e to the x. So again, sometimes we see that with e, and if we think about it, that was a variable, and we're trying to apply the exponential rule as opposed to just looking at it as the power rule, in this case, the scalar. Okay, so down here now we're going to have a product. We're actually going to have the product rule twice, and one of the things to be careful about here is notice we're subtracting. So when we have the product rule, right, you're going to have because we have two terms here, a binomial. Or two terms in that product rule, so we've got to be careful about distributing. Okay, so going left to right, we have the derivative of x squared, which is 2x times e to the x, plus, now we have x squared times the derivative of e to the x, which is just e to the x, minus, so I'm going to use parentheses, the derivative of x is 1, so we have 1 times e to the x, plus, then we have x times the derivative of e to the x, which is e to the x. Okay, so now we should clean this up. Let's see what we have. So 2x e to the x squared e to the x, minus e to the x, plus, or rather minus, x e to the x. Okay, so I have a 2x e to the x minus a 1x e to the x, so that leaves me with 1x e to the x. Plus x squared e to the x minus e to the x. So I think you could leave it like that. If you wanted to factor out an e to the x, you certainly could. And notice you'd be left with x squared plus x minus 1. Okay, so here now, again, we have the product rule we're going to have to apply. So we would have 5 to the x times the derivative of cosine of 4x rather, would be the cosine of 4x times 4, plus, and I didn't leave myself a lot of room here, so I'll come down here. Now we're going to have sine 4x times, now the derivative would be 5 to the x times the natural log of 5. So the one thing I could do is I could factor out a 5 to the x here, and that leaves me with 4 cosine 4x plus the natural log of 5 times the sine of 4x. Okay, let's look at two more complicated problems. So here, the question is show that y equals e to the x plus e to the negative x over 2 satisfies this differential equation. So really what we're going to do is we're going to find the first derivative, the second derivative, and what we're going to do is plug in y here, the first derivative here, the second derivative there, and show that all of that is going to equal 0. All right, so the first derivative, here we have e to the x plus e to the negative 1/2 x times the derivative of negative 1/2 x, which is negative 1/2. And then our second derivative would be e to the x Let me clean that one up first because I think maybe visually that will help you. If I do that, all right, let's clean that up. Where did my eraser go? All right, we'll just. So the first derivative would be e to the x minus 1/2 e to the negative 1/2 x. Okay, so our second derivative, again, e to the x minus 1/2 e to the negative 1/2 x, again, times the derivative of negative 1/2 x, which is negative 1/2. So our second derivative would be e to the x plus 1/4 e to the negative 1/2 x. So there's my second derivative, there's my first derivative, there's our function, and we're going to plug those all in here. All right. So we have 2 times the second derivative. So we have 2 times e to the x plus 1/4 e to the negative 1/2 x minus the first derivative, which is e to the x minus 1/2 e to the negative 1/2 x minus the function e to the x plus e to the negative 1/2 x, and all of that has to equal 0. All right, so let's see what we get here. We get 2 e to the x. We distribute plus 1/2 e to the negative 1/2 x. Again, distributing minus e to the x plus a 1/2 e to the negative 1/2 x minus e to the x minus e to the negative 1/2 x. Okay, so this is a 2e to the x minus 1 minus another 1, so that is going to be 0. 1/2 plus 1/2 is 1e to the negative 1/2 x minus a 1, and so sure enough, that satisfies that differential equation. All right, last one. Find the equation of the tangent line to the graph of 2e to the xy equals x plus y at the point 0, 2. So remember, the two things we need are slope and a point. So we have the slope, or the point rather. So to find the slope, we're going to take the derivative. So we have 2e to the xy times the derivative of xy. So again, we're going to use product rule. So the derivative of x is 1 times y plus x times the derivative of y, which is y prime, equals, and then here we'd have 1 plus y prime. Okay, so we've got some choices. Do we want to distribute and put all the y primes on one side? You could. Or what we can do is just substitute the x and y coordinate for x and y, and then find y prime. So I'm going to do that. So we have 2e to the 0 times 2 times 1y, so 1 times 2 plus x, which is 0, y prime equals 1 plus y prime. All right, so we have e to the 0, which is 1, times 2, so you have 2, that's a 2 plus 0 equals 1 plus y prime. That's 4 equals 1 plus y prime is equal to 3. So the slope is 3. We have the point 2, so our equation would be y minus 2 equals 3 times x minus 0, and there we're done. So hopefully this helps. We'll see you soon.